Just pala.
Hello, we are the researchers. So our research is all about ultrasonic distance measuring device. I'm Elijah Carl M. Talan.
And I'm John Glendale M. Eden.
And I'm Elisar T. Mendoza.
And I'm Riyad Renzo S. Bongola.
Chapter 1, the problem and its background. So measurements have always been very essential to our lives. So we have time, we have weight, we have meter, we have temperature, and we all have units for them. Celsius, seconds, meter, kilogram. And in order to get these measurements, we need devices in order to take them accurately. We have meter stick, measuring tape, weighing scale, thermometer. We researchers, we want to create a device that would be efficient, that would efficiently take measurements in a case of distance.
Okay, here we are, the background of the study. So everything started in the 18th century when the first electro-optical distance meter was invented. And then through a lot of inventions, scientists invented the device called geodimeter, and some engineers and scientists was inspired by the design and patented the device called electromagnetic distance meter. And in the modern era, now the researchers are using the latest ultrasonic sensor, the HCSR04, and the use of this device is very efficient in measuring the distance of two objects, and that's all.
So moving on, this is our conceptual framework. So here we have three parts: the input, the process, and output. So in the input, or in the beginning, we need to have planning, materials or the components needed for the device, and learning resources which we will be using in order to formulate or create the device. In the process, we will be assembling the device, and it will also involve coding in order to make the device work under which we like it to, and assembling theories and how it will be implemented, how it will be assembled, and testing. We will be experimenting the limits of this device. And the output, the ultrasonic distance measuring device, this is when it's finally complete and fully functional. So theoretical framework. In here we have the piezoelectric effect and ultrasonic principle. For the piezoelectric effect, how it works is in our sensor we have the transducer and the receiver. For the piezoelectric effect to work, electricity will be conducted to the transducer, and this will cause mechanical stress within it. This mechanical stress will cause the transducer to emit sound waves or ultrasonic sound waves. For the ultrasonic principle, once these sound waves are emitted, it will go to a surface, and because this is sound waves that we are talking about, it will bounce off or echo, and the receiver will receive this echo. And this is how the sensor or the device as a whole will measure the distance from the device to the object.
Thanks. So now we're moving on to the statement of the problem. So this study aims to create a simple, effective, and efficient ultrasonic distance measuring device. To be specific, these are the questions that the researchers seek to answer. So our first question is it possible to create an effective and efficient ultrasonic distance measuring device with a relatively low budget? Second question is, how much distance can the ultrasonic distance measuring device achieve? So it has two sub-questions. First sub-question is it comparable to any of the measuring devices that are widely available and used? Does it do a better job of taking measurements than the ones that already exist? Our third question is, can the device take measurements with minimal to no errors? And our last question, is it not too complicated to adapt to the device?
So moving on we have hypothesis. The following hypothesis serves as the basis of the study. First is, it is possible to create a simple yet effective and efficient ultrasonic distance measuring device that can take measurements comparable to any of the existing alternative measuring devices. Second, it is possible to create the ultrasonic distance measuring device to take measurements with minimal to no errors. Significance of the study. The relevant results are important to the following groups of people. Future researchers. Future researchers may use this as a reference or as a guide for any topic related they have chosen. Students. Students may choose to pick topics which are related to the researcher's studies in a way so it can be used as a reference. Teachers. Teachers can use this as a basis to guide students who have topics related to the researcher's study. Various professionals. It is significant to various professions like carpenters and engineers to lighten their workload and increase their overall efficiency.
Thank you, Riyad. So now we're moving on to our scope and limitations. The scope of the study will be about the ultrasonic distance measuring device and its feasibility as an alternative measuring device. The study will be conducted in Al-Taj International School, Riyadh, Kingdom of Saudi Arabia. Therefore, the experiment of the device effectiveness will be limited to the vicinity.
Moving on, here are the materials. So the materials here in the picture are, the first one is HCSR04, which is the ultrasonic sensor. The breadboard, the Arduino Uno, and LCD with an I2C daughter board and a 9 volts battery. And the lines here are called jumper wires.
So moving on, we have chapter 2, review of related literature and studies. Related studies and literature. Design of an ultrasonic distance meter, International Journey of Scientific and Engineering Research Volume 4, Issue 3. This study states that through the use of ultrasonic waves at a level of 40 kilohertz, we can use ultrasonic waves as an alternative measuring device.
Thank you, Riyad. So the second one is design and implementation of digital distance measurement system using ultrasonic sensor. According to Sharma and Abro in 2014, the study, when measuring device, there are two methods, contact and non-contact. The researchers will be using a non-contact method because the ultrasonic sensor to be used does not have to be in physical contact with the object to be measured. In order to do so, the sensor uses the propagation of ultrasonic sound waves. The ultrasonic sensor that will be used by the researchers is the HCSR04. The sensor has a transmitter that vibrates short, high-frequency sound waves, sound pulses rather, that which surface then bounces back to the receiver. This method of electronically measuring distance is known as a pulse method. Alright, moving on. The next one is electronic distance measurement, an introduction, Springer Science and Business Media. According to a study of Jean Rueger in 2012, the way which the pulse method works is that a short, intensive signal is transmitted by the instrument, which is the HCSR04, and then it travels to a target point and back, then covers twice the distance. Then this measures the so-called flight time between the transmission and the reception of the same pulse. Then, therefore, the distance can be calculated. There's also another study of Mehta and Tiwari from 2018. They expounded on how the ultrasonic sensor works, and they describe one of the major part of ultrasonic sensor, which is the transducer. The transducer converts the sound energy into electrical energy, and then vice versa, right? Then next one is these sound waves that it emit are in a frequency of 20,000 hertz or 20 kilohertz, which is beyond the hearing range of a human being, and it can only be detected by the sensor itself.
Moving on to the third literature. It is about the evaluation of method of measuring distance between objects and walls using ultrasonic sensors. So, according to Ishihara, Shina, and Suzuki 2009, they are the one who studied the characteristics of an ultrasonic sensor. First, they identified the signal processing is easier because the speed of sound is lower than the speed of light in the presence of air. Second, the relatively short ultrasonic wavelengths allow more highly accurate distance measurement. Third, ultrasonic is not affected by the transparency or color of a surface. Therefore, measuring the distance from such objects does not affect the measurements. And finally, ultrasonic is not affected by the effects of light and airborne dust, allowing it to perform measurements of distance in outdoor environments.
So the goal of the researchers is to create an effective, efficient, yet simple ultrasonic distance measuring device. And we chose the HTSR4 as our sensor in order to do so. So it has its drawbacks and it has its limitations, but these are the reasons why we chose it. So first of all, this sensor allows us to create a device that uses a non-contact method. It doesn't have to be physically in contact with the device, with the object that it tries to measure. Next, in order to be non-contact, it uses the pulse method. So basically, the transducer emits a pulse of ultrasonic sound waves in microseconds. These pulses will allow us to measure the distance between the device and the object. Next, since this is an ultrasonic sensor and it emits ultrasonic sound waves, this means that it is beyond our hearing range. And according to other studies, ultrasonic sound waves do not have any negative effects on our health. So in long-term uses, it won't be negative in our health. And next, the ultrasonic sensor is versatile. Therefore, it has a lot of uses in a lot of applications. Any possible? Haba kasi busy. 2, 3, 4. So these are the limitations of the device. First of all, when measuring distance, the device has to be oriented perpendicularly to the surface of the object. Next, the surface of the object must be large enough, or if it's close enough, or it should be close enough in order for the ultrasonic sensor to detect it. Next, the ultrasonic sensor has a limitation of 400 centimeters in order to accurately measure distance. And lastly, the ultrasonic sensor sound waves are affected by temperature and humidity. Therefore, in poor conditions, the device might not work properly. These limitations, we still consider the sensor. Because first of all, this sensor can still detect transparent objects or an object with any kind of color. So basically, color won't be something that we have to think of when measuring distance. Next, waves are not affected by light or dust. So say for example, a room is dark, the device won't be affected. Or if, say for example, here in Riyadh, it's sandstorm, the device won't be affected as well. And lastly, the ultrasonic sensor is very cheap. Therefore, it's okay with this. We're fine with these limitations because it's versatile for its price. It's cost efficient. In conclusion, the researchers have determined that in order to achieve their goal of creating an effective, efficient, and simple ultrasonic distance measuring device, the best option is to use HCSR4 ultrasonic sensor. Despite its drawbacks and limitations, its relatively low price and versatility in various scenarios justifies its use.
Thank you, Eli. So next one is chapter 3, the research methodology. So first is the research design. The researchers use the experimental design as the research design to gather the data needed to create an effective, efficient and simple ultrasonic distance measuring device. This was the chosen research design because it is the most suitable method for gathering the data that will answer the research problem.
So now we're moving on to the locale and time of the study. The study will be conducted at the first week of March 2019 in the boys section of Al-Taj International School, Riyadh, Kingdom of Saudi Arabia, school year 2018 to 2019.
Following that is the research instruments. The researchers will be using a prototype of an ultrasonic distance measuring device to test its capabilities and how it compares to the alternative devices available today.
Moving on with the data gathering procedure. To begin with, the prototype ultrasonic distance measuring device has to be complete and fully functional. Then the researchers will test the device's capabilities, such as how much distance it can measure, how long it takes to do so compared to any of the widely available measuring devices, the accuracy and precision of the device, and its usability to the consumers through interviews. Moving on with the statistical treatment of data. The researchers will apply descriptive statistics such as mean and percentage to the data gathered with the measuring device in order to accurately analyze the results gathered from the experiments. So the chapter 4, analysis, interpretation, and presentation of data. So the chapter 4 will contain what we have found out from our experiments. So this chapter will also contain summaries and explanations about them. So for the first question from the statement of the problem, is it possible to create an effective and efficient ultrasonic distance measuring device with a relatively low budget? In our case, we found out that no, a consumer would need to have a budget ranging from 150 to 100 riyals in order to create a device. We find this too expensive compared to other devices that are available today. So with ultrasonic sensor, it costs us 25 riyals. For the breadboard, 10 riyals. Jumper wire, 3 riyals. Arduino Uno, 75 riyals. LCD 16x2, 35 riyals. I2C for LCD, 20 riyals. 9 volts battery, 5 riyals. And snap connector for 2 riyals. Second question from the statement of the problem. How much distance can the ultrasonic distance measuring device achieve? So we have found out that the ultrasonic distance measuring device sensor is capable of measuring up to 400 centimeters accurately. Third question, is it comparable to any of the measuring devices that are widely available in use? Yes. The device prototype can measure a comparable distance of up to 400 centimeters. Devices that are widely available today, such as measuring tape, can have a range of up to 300 to 500, and ours can go 400. So it is comparable to the devices that are available today. Does it do a better job of taking measurements than the ones that already exist? Through our experiments, we have found out that the device does a better job in real-life applications in terms of time. So this is a table showing from our experiment. So this is the ultrasonic distance measuring device, and you compared it to a measuring tape. On average, the device only takes 1.5 seconds for any kind of distance measured to take the needed measurements. This one is based on the coding that we have done into our device. For the measuring tape, we took 25 attempts for each distance measured, and it took the average. And as we can see, the distance measured, the farther the distance that's needed to be measured, the longer it takes for the device to take measurements. Next question. Can the device take measurements with minimal to no errors? Yes, the device prototype can take measurements with 1 to 2% margin of error. From our experiment, under 25 attempts, the accuracy is respectable. For shorter distances, we have 100 to 99%. And as the distance grows, it reaches about 98%. For the precision, the device does it well. Through all the tests, it takes 100%. Is it not too complicated to adapt the device? Yes, it won't be complicated to adapt the device in terms of operation. All that needs to be done is to power on the device, and the device will start measuring distance. But according to some of the people that we have interviewed, it will be less complicated to adapt the device if it's placed inside a portable container to be more efficient. So with the analysis of the data gathered from the experiments, the researchers are satisfied with the prototype's capabilities to operate and measure distance. Although it would be quite costly in creating it, the distance it measures is long enough for various cases. It also takes less time to measure distance than a typical consumer device such as a measuring tape. Additionally, it has a respectable accuracy and great precision when measuring distance. Lastly, the device is not too complicated in order to adapt it.
Okay.
Alright, thank you. Now moving on to the last chapter, which is chapter 5. This includes summary findings, conclusions, and recommendations. Alright, here in the findings, is it possible to create an effective and efficient ultrasonic distance measuring device with a relatively low budget? Yeah, for a typical consumer, yes, it won't be cheap because the components can reach around about 150 to 200 reals, so it can be expensive for typical consumers. But then if you are a tech hobbyist, it's no problem and you can reuse the components in other projects. How much distance can the ultrasonic distance measuring device achieve? So the distance that the ultrasonic device can achieve is, for now, the limit is 400 centimeters or 4 meters, which is longer than an ordinary measuring tape, which is 3 meters or 200 centimeters and a 1 meter thick. Is it comparable to any of the measuring devices that are widely available in use? Yes, the device prototype can measure a distance that is comparable to other widely used devices, such as measuring tape or meter stick. We have tried it already. Does it do a better job of taking measurements than the ones that already exist? Yes, the device does a better job in real-life applications, especially in terms of time. If you're in a hurry or you need to take a measurement in a small room quickly, you can use the ultrasonic sensor device, measuring device rather, to measure this small room without any disturbance. Or if you're in a hurry, you can just measure it using this device, and it's kind of better than the measuring tape. And we also programmed it to make it better. Can the device take measurements with minimal to no errors? Yes, the device can take measurements with only 1 to 2% margin of error. This margin of error increases by 1% as the distance from the object's surface grows. Is it not too complicated to adapt the device? Yes, it will not be complicated to adapt the device because of the simplicity, and it's very easy to use. For example, you're just going to turn on the device and then start measuring stuff. Conclusion.
Thank you to Dr. JG. So in conclusion, it is possible to create a simple yet effective and efficient ultrasonic distance measuring device that can take measurements comparable to any of the existing alternative measuring devices. It is possible to create the ultrasonic distance measuring device to take measurements with minimal to no errors. The device may not be cheap to a typical consumer, but the usability of the device's components will come in handy, especially to tech hobbyists or enthusiasts. The device's operation is simple, therefore it will not be complicated, but an improvement on the device's portability would make it better.
The researchers recommend this study to be a reference for the future researchers who are looking for information, especially if it is similar to the field of this study. The study contains vital information that can help improve the future researchers' understanding on the concept of ultrasonic in measuring distance and using Arduino as a platform for creating electronic projects. The researchers recommend that future researchers improve on the prototype made as various aspects of it can be further enhanced by implementing improvements, especially in its accuracy and portability. Lastly, the researchers recommend for future researchers to further look on ultrasonic as it can be widely used for other applications.
Thank you for listening and have a nice day.
That's all. Forced.